All right, welcome back to physics. We are into our second part of our energy unit. And so let's go ahead and get going with that right away. So I am right here get my own picture up and out of the way and get that stuff up and out of the way. All right, we are on our energy bungee jumping unit. And so we started out last time and we were talking about our vocabulary, specifically kinetic energy, potential energy, and what it means to transform energy. So we started in on our Google Doc packet, and it has several parts to it. So I'm just going to jump right into that. All right. So the first thing I had asked you to do was go and do the work in the simulation, the PhET skate park. And so when you go over to the PhET skate park, I'm just going to bring that one up for you. What you see is an exchange of energy between kinetic uh, and potential. So when the skater is way up high, and we're just going to go ahead and bring that one up here. When the skater is way up high on the side of the ramp, her energy, so we can see her energy here, and we start her up high, and she comes down to the bottom. Um, her energy is transformed from potential to kinetic. So when she's way up high, she has lots of potential and very little kinetic because she's not going very fast. As she comes down to the bottom, that energy is transformed into kinetic. So when you watch the total is not changing. And that is all about conservation of energy. So we can transform between kinetic and potential. All right. All right. So that is our little PhET diagram, our little simulation. And so I'm just going to zip back over here for you and go back into our, all right. Okay, so when you were doing your energy diagrams, I described that there were several different ways to do it. Another alternate way is a little application called Cami. So I'm going to bring this into Cami so that we can do a little bit of work with it. And we can actually look at some of the graphs. All right, so I'm going to open this one from Google Drive. I'm going to move this up and out of the way. And we're doing physics and energy and our packet. So when you do Cami, obviously you have to wait just a little bit for the document to open up. But once it's open, then it lets you draw, highlight, and do other things, leave verbal comments, and do lots of different things. All right, so way up at the beginning, okay? So you were going to be working on the skate park. So as an example, as the girl comes down, all right, her kinetic energy does not go down, okay? Her kinetic energy in position 1 is like very little. And then in position 2, it gets a little bigger. Position 3, it gets still bigger. Position 4, it gets a little smaller again. In position 5, it's almost down to 0. Notice that if I go to the potential energy, the potential's really big and then comes down and then is very small and then gets bigger because she's going back up higher. All right. And if I was to look at the total energy, and I'm going to do this one more time here of green for total energy, I would probably have something like this, where the total energy is not changing. Okay, all I'm doing now is adding the two of them together. All right. So when I go and I start looking at other situations, and in this case, I'm going to code gravitational as red and kinetic as green. And I think I'm going to code, maybe elastic as blue. Maybe I'll leave it there. So I'm only going to do a few of these for you. So as an example with the car. So the car beforehand has a lot of kinetic energy. It's moving a lot, all right? And then I'm going to do one more here because I want to do thermal energy. So we're going to do a thermal there too. There's no thermal, there's no potential. The car's just moving. With the road, there's nothing going on. And so my total system, okay, is still the same, all right? Afterwards, after the car has skidded into this parking spot, kinetic is now down to 0. The road has picked up a huge amount of thermal energy, okay? And if I look at the total for the system, we're still the same. It's just that there's been a transformation, okay, from one type of energy to another. All right, I'm going to do the last one here. That we have this guy and he is pulling a massive airplane. And so there's no potential, they're not up in the air. Initially, there's no kinetic, okay? There's no thermal because nothing's going on. So where's all the energy? I'm gonna put it in pink because it is all in chemical energy within his body. So I'm gonna put that this energy is in chemical energy. There's no energy in the plane, but our total energy is still where it was right there. All right, afterwards, now we're getting into, okay, the person is moving, the plane is moving, we may have a little bit of, yeah, he's getting sweaty and the plane is friction on the wheels on the concrete and all that sort of stuff is going on. But if I add all those things up, okay, I got a little of that and a little of that. And then I'm going to go over and get my green and I've got a little of that and a little of that. The total energy of my system here has to equal the total energy of my system here. It cannot change. All right. So next time we're going to go through bungee jumping. So be back here for bungee jumping.